So first, as always, a brief overview of our release plans. We are keeping the same release cadence as always, so 4 releases per year. This is CloverDX 7.1, which we released on 24th of June, and the next one will be released at the end of September. That will be CloverDX 7.2, and before the end of the year, we'll have 7.3. As usually, we expect to have some bug fix releases in between, depending on the security issues that are found and so on. All right, now let's have a look at the highlights of this release. I'll talk about these all a little bit later, and I'll show you a demo at the end of these features. So let's start with the AI. This is something that everyone is talking about. So of course, we at Clover cannot be left behind, and we started working on AI features quite a while ago. And this is the first release that includes several of them. So I'll provide additional details of what these are and how they work a little bit later. Another feature that we improved is the Data Manager. This is something that we've introduced a while ago, and the centralized Data Manager allows you to kind of centralize your data governance into a single instance that you can share across multiple CloverDX environments. This will help you reduce data duplication and prevent silos from building in your different CloverDX environments. We've also added support for reference data sets into Data Catalog and Wrangler. This is something that will allow you to much easier work within your Wrangler jobs with lookups for your reference data, and we'll be expanding this functionality to cover transactional data sets in the next release. And then we've added few smaller things like, for example, descriptions and other properties for event listeners and schedulers to help you navigate more complex environments where you might have hundreds or even thousands of listeners or schedulers navigating complex structures of files and so on. So first, let's start with AI. This is something that everyone has been talking about for a couple of years, and we've been working on some features for Clover for a while. And what I'd like to talk about today is the way we think about this so that you understand how we see this and how we'll be improving CloverDX products and adding various AI or machine learning features in the future. So, there are basically two questions that we wanted to answer when we started working on this. The first one is, how can we help different kinds of users? We have a whole gamut of users ranging from the technical ones who are essentially developers working in designers, some of them very skilled in Java or all kinds of other languages where they have no problem understanding very complex and technical features. But on the other hand, we have quite a number of users who are not technical at all, who just need to work with their data, right? There might be data quality experts or business users who know their data, but they don't know how it's processed in the backend. They just know what needs to happen with the data. And we wanted to make sure that the features that we built cover all of these users eventually. And of course, we also want to make sure that what we build makes sense in different stages of the project lifecycle. So when you are starting, you are requiring something else than when you are already in production and you need to process your data. So when thinking about this, we came up essentially with this kind of matrix that helps us kind of navigate the features that we are working on. On one axis, the horizontal, we have the usage where you can use the AI features for transformation. So essentially, you do something with your data that involves AI, sending it somewhere and so on. Or you can use it in a category that we call productivity. So this is something that helps you build your jobs, your transformations more effectively. And on the other axis, the vertical one, we have the information about where the data is processed, whether this is something that's processed in-house, meaning in your infrastructure, because many Clover instances are deployed on-premise, or even if it's in cloud, it's still your infrastructure, not some sort of SaaS offering. But of course, there are also use cases where you want to share your data with third parties, usually for generative AI use cases and similar, where you don't want to be running your own LLM in-house because that requires massive infrastructure that you for sure don't want to maintain by yourself. And when you think about these use cases, we focused first on the first column, essentially working with data transformation. We are introducing a number of components that help you with data classification and anonymization. All of these work locally, so they run within your CloverDX instance and do not need to send anything to cloud or anywhere else. But on the other hand, we also introduced a new component called OpenAIClient that allows you to transform your data by sending it to OpenAI APIs, essentially using any large language model offered by OpenAI, so that you can do something with your data. We are already working on the other column on the productivity features where we are building the assistant to help you work with your data in Data Manager, where it will learn about what your data looks like and what can be done to fix it. It will be offering suggestions so that you can progress with your data quality fixes faster. And we are also working on the assistant for what we call self-service Wrangler, where it will essentially help you build your data transformations in Wrangler by talking to it rather than clicking in the user interface. And this is something that we expect to be released in the next release or two. So first, let's talk a little bit about the local execution components. So these are components that allow you to run your own machine learning models for data classification. As I mentioned, these are all run locally on the CloverDX server or designer where you started them. So no data is uploaded to cloud, everything is processed where you are. All of these components are in incubation, and I'll show you what they are and how they work a little bit later. What's interesting is about the way this works is that the components essentially provide an interface between your data and the machine learning model. You can get those models from other places. You don't have to be machine learning expert to build and train your own models. And most models that we've worked with and used come from places like Hugging Face, or for example, you can get it from GitHub and so on. These are models built by companies who have like massive, in many cases, AI teams like Google, Meta, Facebook, and others, right? So they all provide free models for you to use in different use cases. They are all optimized for different kind of use cases. And these models are all in a standardized PyTorch format, so we have not invented something new, but rather we are using industry standard, meaning that you can really get anything integrated into Clover as you need. And one very good point about these components is that everything runs within your infrastructure, meaning that if you are processing any kind of sensitive data, you do not have to worry about the data leaving your system and, for example, contributing them to some sort of AI model training for someone else. But on the other hand, of course, there's a little bit of a disadvantage that you have to have hardware to run this. You can run everything on CPU, right? But it will run relatively slowly, or you can get some more powerful hardware and run accelerated versions of those models with much better performance. And I'll talk about that a little bit later. So these are local transformations with machine learning that you can run in CloverDX 7.1. As I mentioned, we also introduced the OpenAIClient component that allows you to work with cloud-hosted models. In this case, it works with OpenAI API and allows you to send your data to OpenAI API, sorry, and again, use different kinds of approaches to process the data there. The component is really flexible and it allows you to do pretty much anything you need. In this case, you do not need to have any extra hardware, right? Because only like small processing happens within Clover, and the heavy lifting, the actual LLM runs in the cloud. But on the other hand, of course, there's cost associated with this because you will be paying OpenAPI and you have to have an account there to be able to use this functionality. So first, let's talk about this OpenAI component. As I mentioned, this is something that allows you to very nicely interact with OpenAI large language models in the cloud. You can pick any model you want, right? There's many of them available, ranging with different capabilities from simpler ones that are cheap all the way to more complex ones, the more recent models that are slower, more expensive, but also can do much more with the data that you submit there. To use this component, you will require the OpenAPI key. You can see that on the screenshot in here. You put the key into the component and it uses your account. And so if you already have account, you just get the key from OpenAI and put it in there. If not, you will have to create one. This means that, of course, OpenAPI will bill you for for the API calls you make. It tends to be pretty cheap, right? The models that we've experimented with are usually like very small fractions of a cent per record call. So even if you run thousands of executions, it doesn't get very expensive. What's interesting about the way the component runs is that we're thinking about how to make this as flexible as the rest of the CloverDX platform. So we've come up with a way to interact with the model that allows you to implement pretty much any use case you want. You can do something very simple where you just send the data and get the response uh, from this from the LLM, or you can do something more complex where you actually lead discussion with LLM, and depending on what it responds to, you can respond with something back and kind of loop in discussion. This is something that even allows you to implement something like agent, right, where the agent talks to the LLM and figures out something based on the response and further leads the discussion. I'll show you how this works in a couple minutes. As I mentioned before, this is an incubation component, right, and it runs. Your data is uploaded to the cloud and it's processed there. On the other hand, we have a number of data classification components. There are 3 of them that are pure classifiers. These all run locally. So meaning that whatever you process never leaves your environment, all gets processed by your CloverDX server. You can also use them in Designer, although I do not expect that to be very common given the performance requirements if you want to process anything larger. The components that we have introduced are meant for data classification with 3 different classifiers that allow you to classify tokens, kind of like words within your data, or the whole text. Often this is used, for example, for sentiment analysis to figure out whether something is positive, negative, or so on. Or you can use it to find personal data within your data and so on. I'll show you an example of how that works. And again, in this case, we have been thinking about how to make this work in the most possible flexible way. So the way that these components work is that, again, they are providing the interface between you and the machine learning model that you get from somewhere else, right? You need to package the model for Clover to be able to understand it, but that usually is not too difficult. And whatever the functionality in your model is, that's what the components will allow you to do. Right? So if your model recognizes, for example, 10 different data classes, the components will know 10 different classes. If you have more complex model that recognizes 50 classes, it will do 50 classes. And so you are not limited to just a subset of models. Anything that satisfies the classifier interface for token classification, zero-shot classification, or text classification will work. The interesting way about how this works is that these models are shared via CloverDX Server. So you deploy them as libraries, and you can then use them in any project within the server. You can do something similar with Designer only, local projects, but of course there's no sharing with anyone because at that point it runs on your machine only. And I'll show you an example of how these components work in a few minutes during the demo. So these are the data classification components. We have one more component that's a bit of a mix. It's on one hand a classification component, but on the other hand, it also does data transformation. And this is the AI anonymizer component. This is essentially a combination of a token classification, which uses the machine learning model that you provide, and then an automated transformer that allows you to apply masking to the data that was flagged during the classification. You can see a little schema that shows how this works at the bottom. You can get, for example, something like this, right? You get a text that has some personal information within it, like the name, the date of birth, and so on. You run it through the token classification. The component does this for you, so you don't have to do anything there. And it classifies the words within or tokens rather, within the text into different classes, right? For example, we have one of the models as an example that knows classes like given name, surname, date of birth, or city, and so on. You can configure some of these classes to be considered for anonymization, like in here, the red ones, like the names and date of birth, and some might not be considered. Right? For example, city. I don't mind that someone was born in Ulm. Right? It's not that small of a city, so it doesn't add too much. And then the component will run token masking, producing something like this in the end. And this is something that, again, runs locally within your machine, which is exactly what you want for anonymization. Right? You don't want to upload your private data somewhere to the cloud just to be anonymized and to be sent back to you, right? So this is why the component works in this way. And you can use any model that works for data classification for you. So you can get models that work for different languages or understand different data classes and so on. Essentially anything will work within the component. And as I mentioned, one thing that's interesting about how this works is how you get models or the machine learning models into Clover. what you typically do is that you can get the models from somewhere else, from repository like Hugging Face or similar, and then you need to wrap them in CloverDX library. This is functionality, the libraries is a functionality that we've introduced about 4 years ago and essentially allows you to add new functionality to CloverDX without having to upgrade or anything like that. And for the machine learning models, we already provide 9 or so libraries within our marketplace. You can have a look there. I'll show you what it looks like. And you can install any of them from your server, right? Through the libraries module, you can install these. And as soon as the library is installed, the machine learning model will be available for use in any project that is in the server. You are also able uh, to see what the models are, their parameters, and additional details in a new page within the server console that shows the list of models that you have available. And I'll show you what this looks like during the demo. And one interesting thing about machine learning is, of course, the performance, right? This is something that pretty much everyone asks about. You can, of course, run this on CPU, right? There's no problem with that. It works quite well. It is the safe option because it will work every time, right? But you can also run with hardware acceleration if you have NVIDIA GPUs. This runs orders of magnitude faster than the CPU execution, but of course you have to have the hardware and the whole software stack configured for this. To make this easier, we have created a new Docker image that's available on our Docker Hub account, and this image is pre-configured with all the dependencies so that you can take advantage of GPU acceleration for your machine learning workloads. So the only thing you need at that point is the hardware. And the easiest way to try that is to use machine learning instances that are available on AWS, the G5 or G4. They have everything that you need. So if you run an instance of these, they already even have Docker installed. So you just do like Docker pull and put the repository there, and it will install everything for you, and you will have an instance that allows you to work with machine learning with GPU acceleration. So this is the easiest way of testing that. But of course, if you'd like, you can deploy this anywhere else with the hardware if it has the NVIDIA GPU, or you can even install manually, just like always, just like it's always possible with Clover. All right, so now let's talk about something else than AI. I'll show you all of these a little bit later. Uh, the Another quite large expansion of the data manager functionality is what we call centralized data manager. This is the ability for the data manager to service multiple instances of CloverDX Server. And before this version of Clover, you were able to have an instance of data manager within each server that you have in your environment, and each had a copy of your data. This, of course, is great if your servers are supposed to be something else and are not supposed to share data. But if you need to have, for example, some shared reference tables, or you want to have more centralized data governance, uh, you would want this to be centralized in some way. And this is exactly what the data manager can do now. You can configure one of your servers to be like the owner of your data sets. So everything happens there. That instance of Clover manages the data sets and everything else. And you can have any number of other CloverDX servers that just connect to the centralized data manager and pull and push data to it. This is completely transparent to jobs and users on server A or server B, right? So these users do not know that they are using centralized instance because it works in the same way. The translation layer between Clover instances takes care of all the API communication, the network synchronization, and all of that. So this really allows you to have one place where your users go to manage your data. For example, your data stewards or data experts go there to see what's happening with your environment. They log in there, they work with their data there, but the automated processes can happen on a different instance. This is especially useful if your automated processes need to hit tight SLAs, because typically users, you can have spikes, right? For example, at the end of the month, you will have significantly more users working with your data than somewhere in the middle because they need to finish their month, right? Closing the books and so on usually happens towards the end of the month. So this way you can split your instances in a way that allows you to make sure that your automated jobs run predictably with predictable performance, and your users still get an instance where uh, they are free to do anything, run jobs manually, and so on. but still get access to the same data. At the same time, we've made connection between the Wrangler and the Data Manager Tither. You can now access all your reference data sets in Wrangler very easily. They are now listed in the data catalog. You can see that on the screenshot on the right, and there are all these data sets that are in here visible with a little red icon. Those are data sets from the data manager. For each data set, you will get a source and a target, so you can read from it and you can also write to it. This means that you can create Wrangler jobs that populate your data sets or even jobs that use them as lookups. Probably the more common functional will be using them as lookups, but you can write to those data sets as well. We will be expanding this functionality with transactional data sets and full error handling in the next release. So there will be even more stuff in here that will make it even more comfortable for you to use your Wrangler jobs to to work with your data that flows through the data manager. And then, of course, as always, there are many other smaller changes that we implemented. One notable change that can help, especially in those organizations where you have a lot of schedulers or even listeners, is the ability to add a description to it. So this is what it looks like in the UI. You have a new field for descriptions where you can put free text. And then we also added new properties that help you figure out when something was created and then when it was last changed. So these are displayed underneath. When you are searching for something in schedulers or even listeners, the search will also do full text search within the description. So it will help you find anything that you need as long as the descriptions are accurate. And so this will be especially useful for those users who have hundreds of listeners or schedulers. We also made a number of backend changes, especially if you are using cluster. You will need to look at the configuration for the communication between the nodes because we've changed the technology. We are no longer using JGroups, but we are using gRPC for this. This gives us better performance and reliability, also additional security options for that. So especially if we are using HTTPS or rather TLS configured for inter-cluster communication, please have a look into the configuration. All of this is of course documented, so you will be able to see what changes you need to make in your setup to get this to work. We've also added configuration for the embedded Tomcat. This is the instance that runs, for example, your data services and so on. And the new configuration allows you to configure greater security for your instance, essentially by hiding some of the error message details. By default, Tomcat error message, for example, contains information about which version of a Tomcat it is. And this is something that when you want to have the most secure environments usually is not allowed, right? You are not supposed to reveal anything about the environment. So you can configure the internal instance to hide this kind of information as well. Right, so that's it for the theory. Let's now have a look at the demo. I'll start with the AI stuff, and I'll start with the libraries and the models within the server. So for this is a server which actually does have a GPU installed, so I can also use the accelerated models, and I've installed 4 machine learning models on this instance. You can see them listed as libraries, and when you look at each library, the libraries have the machine learning model listed in there. Where it gets more interesting is when you look at our new AI ML screen. This is where you get more information about what's in there. You can see the models that are included there. You can see, for example, that the first 2 are from Facebook. And so, as I mentioned before, we are not building these. We are just using the models that someone else built, someone with a lot of AI experience. You can see basic properties of the model, what's the size, what kind of model it is, and you get a bit more when you click on it. Of course, given that these models are third party, we also want to provide as much information as possible. So you can also click on a link that gives you to the original place where the model was published, where you often get a lot more information. For many models, you even get statistics about how good it is and so on. You can download various testing data and all of that. But it depends on model. Not all authors provide that kind of detailed information. So now that you have the models installed in here, or actually one more step, this is where you get them, right? This is our marketplace. And as I mentioned, we have a number of machine learning models available there. Each is a library. They tend to be pretty big, especially the zero-shot models are large, but even the smaller ones are easily hundreds of megabytes in size. So this is a very different compared to the usual libraries. We don't even publish size for those. These are usually kilobytes or a small number of megabytes in size. So when you are installing any of the AI ones, uh, it will take a while for the thing to download and install. Of course, if you click on this, you'll get the information that you can see in the UI, right? So more details about the model. And the best way to to install them is through the libraries, right? Through the marketplace. All of that is pre-configured for you when you when you install CloverDX 7.1. And so this is, for example, the way to install a model, right? If I click on it, it will start downloading. I'm not going to do that now because it will take a while to get a new one. But once you do that, the model immediately becomes available and you can use it in your graphs, right? So let's have a look at that. Let me actually open the correct project. I have two versions of it, and this one runs on the instance with the GPU. This is a very simple graph that shows how the token classifier is used. I have sample data that contains various personal information like social security numbers, credit cards, phone numbers, names, and so on. And the classification model that we are using for this is called Piranha. Right? And the models that you have available are all listed in here. If I had more, of course, the list would be longer. There's a lot of options that I'm not going to go into detail because this is fairly involved. And usually to understand what this means, you have to read the documentation for the model. But we can see how this runs. So let me run this one. It will take a couple seconds to finish, and I had it stop at 3,000 records so that it doesn't take too long. But you can see that it processes data fairly quickly. I can also switch to the CPU only, and this is a fairly big server. I think it's got 32 cores or something, so it's not a small instance. And the CPU processing will still be significantly slower than this. I don't think I've ever waited for it to process 3,000 records. What's interesting is what kind of information you get at the end. As usually for Clover, we wanted to make sure that you get something that's useful to you, but also at the same time that's as close to what the model provides so that you can use as much information as you have. So it gives you a variant with the details of all, in this case, of all the tokens that were detected that contain some sort of personal information that the model understands, right? So this is very detailed, and you can use all kinds of components afterwards to do something with this information. And the simplest way to do something with this is to anonymize this. And I have a different example that shows the flexibility of our models or of our components, right? This is something that actually, let me do this, that allows you to connect multiple components in a row, right? Oftentimes you'll end up using multiple models. For example, in here, I'm using the text classification model to figure out whether product review is positive or negative. And then I also am running the AI anonymizer component on it to get rid of the personal information. So let's run this. So that we can see. Okay, sorry. I think I moved the project in here. All right. Okay, I didn't install this one in here. So, but if it was running, you would see the output very nicely. I can actually run that over here in the other project that I have. This one. This one uses CPU only, so it will be a little bit slower, but the data is not very big, so can wait for that. And the interesting thing is that the way that you can work with this allows you to pass data between different components. So uh, you can kind of extend the results produced by one model with additional model. And in many cases, this is fairly difficult to do when you use other frameworks. And in Clover, it's very easy. You just feed data from one component to the next one, right? And in here, we can see, for example, the output from the text classification, right? And this is after parsing, we extract just the information that we want, whether the review is positive or negative, and afterwards, at the end, we anonymize that, and this is the anonymized version. And you can see there is some data masked within the text, so that the personal information is covered. Of course, this depends on the quality of the model that you have, right? You might download a model that doesn't work very well for detecting the information in the data that you have, but it's still something that you will be able to use. So this is how the four components work that we have, and they are all in their separate AI/machine learning category within Palette. Please remember, these are all incubation. We will be evolving these components further, so their interface might change, right? They might require additional parameters or might produce data in slightly different format, but we expect them to keep functioning this way going forward. And the last one is the OpenAI client. So let's talk about that one too. And as I mentioned, this is an interesting component from the point of view of how it works with the LLM, because it allows you to send data to LLM and lead conversation with it, so that you can react to what the LLM responds to, right? So in my case, let me actually just run this. I don't have that much data there again to let it finish quickly. So I have product reviews. This case, they are much longer, and each is about this long, and it's a review for a product. And what I want is to extract useful information out of this. This is unstructured text, and the LLMs are very good at extracting data from large volume of text. And what you can do is you can provide a system message, which is kind of like the system prompt, and this is what the LLM will be, and then you have the processing code. And in my case, my LLM will pretend that it's a customer success team member trying to extract useful information from the review. And then on top of that, I have the processing code, which in my case is a little bit more complex. Oh, well, because what it tries to do is it tries to lead the conversation, because in some cases the LLM responds with something that I don't understand. It might respond with something that's not a valid JSON. So I'm trying to just tell it, it's not a valid JSON, it contains an error, fix it. And this kind of thing you can do very easily within the component, even more complex flows, and it allows you to very easily interact with the machine learning, with the LLM in a way that allows you to implement, as I mentioned, even kind of like agentic behavior if you want it. And in this case, I'm feeding the response from LLM, and this is what I get back, right, as a text, and I'm feeding it to JSON parser to extract the data from there, right? And we've tested this with all kinds of different use cases. For example, we've tried extracting data from invoices, even like providing pictures and it to the LLM, and gives you back the extracted data. So it can be used for all kinds of functions, and I'm pretty sure that our clients will come up with interesting use cases. And as I mentioned, the only thing that you need to get this working is the API key, and you can pick different models offered by OpenAPI. If they start offering something new, we'll of course release an update where you will be able to get a new model, new LLM, and use that if there's something interesting with interesting capabilities. All right, so that was the AI and machine learning. Let's now have a look at the Wrangler and the Data Manager. First, I wanted to show the Data Manager. When you look at the settings for the Data Manager, you can now see this, right? Before we had a simple configuration for just the database, but now we have expanded that to allow you to configure where your data manager is located. So you can use remote data manager and then just configure a server instance where it is hosted. At that point, meaning that the data manager belonging to this server will turn off, and your data will be all hosted on the server that you specify in here. So I'm not going to do that and return that. So this is the configuration for the centralized data manager, and that's it. You don't have to do anything special in your jobs to take advantage of that or anything else. You just have to have two servers. One of them will be hosting the the data manager instance, and the other one will be connecting to it through this interface. All the jobs and everything else will keep working as it was working before. Right, and then the second part of this that we implemented is the ability for Wrangler to use uh, to use the lookup tables from reference data sets. And this all starts in the data catalog. You can see there are lots of them, and they all correspond uh, to reference data tables that I have there. For example, if I look at this one, as always in the data catalog, you get information about what's in there, and so you get to see the layout. You can also see the data preview, right? In my case, the table I clicked on is a list of countries and various names that you can use for them. This is used in an address validation use case, right? And of course, I can see the same thing in my data manager instance. This is it, right? This is the data set that I was looking at. If I keep making changes in here, they will, of course, real time show up in here. It only shows the approved and enabled rows, right? So the ones that are kind of in production, if you have something that's disabled or not approved, it will not show up in the lookup, just like you would expect, right? You don't want lookup on some sort of disabled row or something else. So this is the sources. Of course, we have the targets that allow you to write into those data sets as well. And let me show you how that works. So I have a simple job that loads exchange rates, right? I have a number of exchange rates with just the rate itself. It's exchange rate between a currency and a USD. And I can map it into the target just like this. And so very easy, very simple interface for Wrangler users to load your data into Data Manager. I'm not going to run this because I've already done that before, so it would not have any effect. Where it is more interesting is the ability to use the lookups within Wrangler jobs, and this is what I'm doing in here. Right? I have a use case where I'm reading invoices, converting currencies from whatever the currency it is into USD. And to do that, I need the exchange rates table. And before we implemented this functionality, you had to have a separate data source within Wrangler that stored the exchange rates, and it could have been a file or an API or something else. Now that I have the exchange rates loaded in Data Manager, I can use it like this. I can just come in here and in my lookups pick the lookup that's created based on the Data Manager source. And that's it, right? The only thing that I had to change afterwards was just to make sure that the column mapping works for me, and that's that. So it's as simple as this to be able to use uh, to use reference data sets within your Wrangler jobs. All right, and the last thing that I mentioned are the descriptions for schedules. As I mentioned, that's something that's been added, right? So when you are creating new schedule, uh, you can uh, you can type your description in here, and whatever will work. It's not formatted in any way, but the full text search will search through that, and you can see it used, for example, in here. And I have a description, and we also track the information about when given entity, the schedule or even listener was created, and when it was last changed, and who was the user who did that. And in my case, I did both. But this can be very useful in larger environments where you have multiple people who can configure something on a server. So you have much better visibility of who changed something. Obviously, this gets updated when you import or export configuration and so on. So regardless of how you make the change in your schedule or even listener, this information will be tracked for you.